The rise of microcontainers when less is more. I've been recently experimenting with the concept of microcontainers. And what is a microcontainer? It's a container image that is under 100 kilobytes. I've seen many Python developers brag about using containers to ease software development. Then I look and they're 5 gigabytes. Well, I wouldn't say that's much to brag about because that's going to be very expensive, slow to work with, etc. You can build images that are under 100 kilobytes with languages like Rust, also Zig, Go. These are all options for building these. And they're also revolutionizing the way you think about containerized deployment, because if you strip away everything except for a binary, and again, this is the issue with scripting languages, this option doesn't exist. But with compiled code like Zig, like Rust, like Go, you can have these really small binaries that can do new things that are not really available from a scripting language. Let's take a look at the first use case that I'll talk about, which is edge IoT deployment. You can see that a microcontroller that has 4 megabytes of flash memory could fit really well with a very small 100 kilobit container. I built some Zig code just a couple days ago that was 16 kilobytes. It was a web service that returned back some values, and I could see how I could barely change that and still keep it well under 100 kilobytes. Also, the updates could fit in potentially half of the available flash memory easily, right? The 2 megabyte limit. You could also eliminate base OS as well. You could eliminate firmware updates. Some examples of when you would use this would be a temperature sensor, could be a really good example. You would have this sensor that would just be looking for the temperature, maybe next to crops outdoors somewhere, and it could be using MQTT protocol, and the total would be, let's say, 60 kilobytes, and you could put these all over the place, and they could give you a good, maybe like a prediction on crop growth, etc. Let's also take a look at browser WebAssembly integration. This is another emerging area that I'm pretty interested in, is WebAssembly. And why do I care about WebAssembly? It's that you can do micro-frontends that load in milliseconds, and then each UI component is isolated in its own container. And you could have direct mapping between the WebAssembly modules and the containers, and you could have zero initialization overhead for route changes. So this could be a very interesting way to develop web applications. Serverless cold starts. This is another one. So with traditional servers, they could take 300 milliseconds to start. But if you have a stripped container, you can initialize things in 50 milliseconds, no file system or OS overhead, and you have direct memory mapping of this single binary. So you can get really true real-time API responses. A fourth use case would be security through minimalism. So no shells, no shell injection, no file system, no path traversal, no OS utilities, no privilege escalation. The single binary is the thing you have to audit. So it's a zero trust architecture. We also have embedded Linux services. So Raspberry Pi, for example, would be a good example, which these often have, let's say, 500 megabytes of RAM, which is more than you need. Each service could contain under 50 kilobytes, and you could run 50 concurrent services easily. This could be perfect for a home automation hub. Also, continuous deployment speed. So again, a traditional base image is 300 megabytes, or in the case of Python, maybe 5 gigabytes. The microcontainer could be 20 kilobytes. So the pipeline could be 10, 15, 20 times faster. You could get reduced bandwidth cost, and you could also do faster rollbacks and canary deployments, and also mesh network distributions. If we go into another category, you could have edge-based nodes that share things with peer-to-peer communication, and you could have minimal bandwidth between those nodes. You could have quick propagation through the network. You could have resilience to network partitions, and these are perfect for remote or disconnected operations. We've got a few more here that I was thinking about. So FPGAs are pretty interesting because they let you program the chip itself, and these are available actually on AWS. So you could have a container that is a FPGA bitstream wrapper. You could have fast switching between different algorithms, minimal memory footprint. You could have a bridge between software and hardware. Another category would be unikernel comparison. So you could have containers versus a specialized OS. You could have different security models, performance trade-offs. And then finally, if we get into a cost analysis here, a traditional Lambda container on AWS maybe is 140 megabytes, but a microcontainer is 50 kilobytes. So is there even a different style of concurrency that you should be considering about? And this could be 2800x reduction in storage, faster cold starts, lower billing, higher density. So a few things to think about here is that the containerization, it has been an interesting paradigm because it's just a different kind of virtualization. And I've been using containers actually since the 2000s with Unix OS like Solaris containers. In fact, I used those in the 2000s, and those are pretty interesting. But if you think about the place where we're at now is, can you get small? Can you get minimal images that unlock new possibilities, serverless architectures, embedded systems, and how can you actually think about things in kilobytes? So I'm actually thinking in a very different way now about containers just by my experiments with Zig. Is how small can I make a container, and can I fit most of my containers under 100 kilobytes of memory? And I think that's a very interesting scenario to play in. And I think in many cases, if you use the scratch container, which has nothing, the size is 0, you build a binary and you strip it, like in the case of Zig or Rust, you can strip these binaries and make them very tiny. You can build a container that is essentially just a binary that gets executed inside of the Docker container runtime. And it's a very interesting new paradigm.